everybody have 8.4 in front of them right now? All right, let's roll today here, guys. So we've been spending a little bit of time last section looking at midpoint formula, distance formula. One thing I'm going to tell you is this: distance formula is not going to go away from us today, okay? And we'll revisit that here in a second. But guys, 8.4 is titled Perimeter and Area in the Coordinate Plane. Kids, if I talk about that word perimeter of an object or perimeter of a shape, what's that mean? Like, sorry, say it one more time for me, Skylar. So going around it then, so like the distance around it. Okay, I would agree with that. Then how about the area of a shape? If perimeter goes outside of that, what's area? It's the number of squares that can completely fill up the inside, right? Okay, so we're going to look at this in terms of a coordinate plane today, and the question we're trying to answer, my friends, says this: how can you find the perimeter and the area of a polygon in a coordinate plane? Okay, so we're going to load this question right here. Guys, we have a front-loaded question right here. It says, is the following figure that we're about to construct a what? Square. Okay, well, let's talk. Okay, it says on a piece of paper, graph quadrilateral, A, B, C, D in a coordinate plane. Label the points A, B, C, and D as labeled by their X, Y coordinate. Okay, so we're going to do that in the coordinate plane down there first. So let's start with part A. Kids, how do you get to the point 1, comma 4 here? Okay, when you say over, specifically what direction? Right 1 and up what? Okay, right 1 and up 4. So I'm going to go right 1, up 1, 2, 3, 4. I'm going to put that point right here, and we're going to label that point. What point, kids? A. Okay, whoops. Give me a second to fix that. Okay, we said this point was point A. All right, how about the coordinate point B? You guys have it on paper, right? I can't see it right now. What's point B's coordinate? Negative 3, 1. How do I get to negative 3, 1? Left 3 and up 1. Okay. All right. And this coordinate is what label? B. Okay. How about your coordinate for C? 0, negative 3. My friends, how do I get to 0, negative 3? Okay, like that. Okay, and then how do I get to D? What's that coordinate? 4, 0. So right 4, you all agree with that? Now, kids, if I make the connection on everything here, first of all, does it appear to be a square? It does. Okay, there's some things we're going to have to prove that make it a square. Okay, so I'm just going to connect all our lines, or our points. So all these segments A, B, C, and D. Okay. So when you've got those points plotted, I think the best thing to do here, kids, is this. It says on a piece of paper, label the points. Okay. Guys, on part A, is it okay if I write see the graph below? Is that okay for that? Okay. Now, the first thing it says to do is find the perimeter of what? Yep. Problem is this. Guys, can I just count the distance on this, or are we going to have to use a distance formula? It's not a horizontal or vertical line, is it? No. Okay, so let's find that distance from A to B right here. I'm going to do this. I think the best thing I can do is this. To get from A to B, we've got to go over a certain amount and then down a certain amount, don't we? Okay, how far over from A to B do we go? How many units does that look like? And then how far down from A to B? 3? Okay. Guys, couldn't I do like Pythagorean theorem here to figure out what this one side, I'm going to call it distance D, would be right there? Would you agree with that? Okay, so watch what I do here. For A to B right here, I'm going to say from segment A to B, I'm going to say that distance would be the same as 4 squared plus 3 squared would equal d squared by your Pythagorean theorem. In a way, we said distance formula is a fancier version of the Pythagorean theorem. Guys, help me with the math on this. What's 4 squared? 16. What's 3 squared? What's 16 and 9 add up to? 16 plus 9. 25, right? My friends, quick question for you. What's the square root of 25? Nice number. What's the distance from A to B have to equal then, kids? 5. Okay. I'm going to show you something right here. Guys, we got a distance of 5. When two of these lengths here, we had a horizontal length of 4 and a vertical length of 3. Made this hypotenuse 5 right here. Watch what happens as I continue to go around this square. Let's go from B to C. Guys, to get from B to C, how far down do I have to go? 4 units. How far over? Oh, I went a little too far. Hang on a second. Guys, don't you have that same 4 and 3 value again right there? So what's the distance from B to C going to be? Okay, so that means that B to C would have to be the same thing. It would also have to be 5 as well, wouldn't it? Do I need to write the 4 squared plus the 3 squared equals d squared again? Or are you just with me? If you have a 4 and a 3, it's going to make a diagonal distance of what now? 5. Okay. Hey, guess what on C to D, my friends? How far over? How much? Close. It's over 4. I think you're a step ahead of me. And then up how much to get to D? Which is going to make the distance from C to D what else then, kids? C to D must be what? Okay. And then D back to A. Guys, you want to guess what those distances might be for vertical and horizontal paths to get from D to A? 4 and 3. Okay. 4 and 3. Oh my gosh. They are 4 and 3. Up 4 and over 3. Which is going to make the distance from D back to A what? Okay, so in part B, it says find the perimeter. Well, what do all sides equal here? What's 5 times 4 sides? So the perimeter must be what? Yep. Your perimeter is 20. Okay. Guys, do you see how I drew like a right triangle right here to figure out a diagonal distance here each time? And then once I had those same distances for every diagonal in terms of 2 legs that were horizontal and vertical, if the value is 4 and 3, it meant that those sides of that yellow, well, we think it's a square, was going to be 5 on all 4 sides, right? Okay. So part C says, are the adjacent sides of the quadrilateral perpendicular? Okay. You guys talked about this last year. I don't know what you remember, but guys, you remember talking about slope, rise over run last year? Okay. Guys, in a slope right here, to go from this point, B to A, how far would you rise? 3. How far would you run? 4. Okay, take a look at this one. Okay, this slope would be 3/4 then, right? Okay, this slope would be down 4, so negative 4, and then right how much? That slope would be negative 4/3. Okay, I'm going to talk about this. I'm just going to use AB. I'm going to use side AB and side BC as the example. I'm going to see what you remember from last year. Anybody remember how the slopes of perpendicular lines were related? We talked about parallel lines last year where the slope was the same for parallel lines, but there was a tricky one. Anybody remember this? It's a 2-word phrase. The first word is opposite. Say it again, John. Opposite reciprocals. Okay. Yeah. Question? No, just stretching. Sorry. Okay. Opposite reciprocals. Yeah. Guys, what's the slope from B to A? Rise how much from B to A, kids? rise, run. The slope from AB is 3/4. Okay? How about the slope from B to C? Your rise is actually going down 4, so what? Is that a positive 4 movement or negative 4 movement, really? Going down from B to C. Negative 4 over the run of what here? Okay, the slope from B to C is really negative 4/3. Kids, when I say opposite, for opposite reciprocals, opposite means one's going to be positive, one's going to be negative. Do we have that situation here where one slope is positive and one slope is negative? Clearly. Okay, then the reciprocal part. Does 3/4 flip into 4/3? It does, doesn't it? Okay. So they're opposite reciprocals. And if you go all the way around this, it says, how can you tell? You would say all slopes, I'm going to say it this way, all adjacent slopes, adjacent meaning each side is touching each other. All adjacent slopes are, what's the phrase again, John? Opposite reciprocals. Guys, what's the word perpendicular even mean? Makes an angle of how many degrees? Yeah, if we're talking about a square right here, my friends, really, what angle do all the angles have to be on the interior? Well, they'd have to be 90 degrees, right? And when we see that slopes are opposite reciprocals of each other, like the rise and run here is 3/4 and the rise and run here is maybe 4/3, that means that angle B has to be what angle, kids? Got to be a right angle, doesn't it? Okay? And that would be the case all the way around here, all right? So here's the deal, kids. A square. All 4 sides what? Equal. Are all of these angles that the sides meet at going to be perpendicular based on that idea of opposite reciprocal for slopes? Your answer to that's going to be what? Yes, it is. Okay. So it says, what's the definition of a square? Well, the definition of a square, my friends, is all sides equal and all angles 90 degrees. Is this a square? What are you going to say? This is a square. Boom. Just like that. That will be a square. All right. Let's move on. You guys got everything? Okay, let's get started right here. So, guys, some goals today. Looking at classifying polygons. What's a polygon, kids? What's a polygon? Any closed shape with straight edges. Very good explanation there. I love that. Haley, pretty sharp today. Okay. We're going to inscribe some regular polygons. Ooh, that sounds like fun. Inscribe regular polygons. We're going to look at finding perimeters and areas of polygons in the coordinate plane. All right. Okay, so the first definition up there is polygon. Haley, you want to read that for me? Because you already know what a polygon is. Polygon must have at least how many sides? What's the smallest shape you can draw with the least amount of sides? Triangle, right? Okay, so I'm going to write down it's a 3 or more sided figure. Okay, triangle being the smallest. Okay, guys, you know what a side is, right? Okay, if I draw this right here, if I call this triangle ABC, what's the name of one side? Side AB. You could say side AB is a side. What's another side? BC. Okay, what's another side? CA or AC. Okay, you know what the sides are. Okay, so an example, I think you've got that. Okay, guys, the vertex is always any what? Corner of a polygon. I always tell kids it's the angles. Doesn't a corner kind of form an angle all the time, kids? Would you agree with that? Okay. All right, at engon, number of sides a polygon has. So if I say you have a 16-gon, how many sides are there? 16 sides. Now, there's specific names for all of them. There really are. Three-sided figure is called what? Okay. This is the one I always get tricked up on. There could be a lot of different names for a four-sided figure, but what one name classifies all four figures? Quadrilateral. I struggle with that word all the time when I say it. Quadrilateral. Quadrilateral. Say it quickly 5 times. Oh, nobody's going to do it. Oh. Okay. All right. Guys, here's one that's going to be new for you guys. I think convex and concave, new for you. Okay. The best way I can explain it to kids is this. All right. Convex. The first 2 words I put up there, and I'm going to highlight this. I think that this is what you should do. Okay. It's not dented anywhere. All right. You're like, what the heck is that part not dented? Okay. What it means is this. Okay. I'm going to ask you if the polygon is convex or concave in this section, and you're going to be like, I don't know what that means. So I'm going to tell you what convex means. If I draw, let's just draw a rectangle right here. Got a rectangle? Convex says a figure is convex, meaning not dented. It says all segments lie inside the polygon. Kids, if I told you to come up here and pick 2 points anywhere in the rectangle, I don't care. If I said, Skylar, go up there and pick a point. So she came up there and drew a point inside the rectangle. And then I said, Emma, draw a different point or pick a different point up here in that rectangle. If I connect those 2 points, the line that connects the 2 points, will that ever go outside that rectangle? Okay, I'm just going to start scrolling around. Somebody tell me when to stop, and I'm going to pick a point. And go. Those are the 2 points I picked. If I draw a point, or if I draw a segment between those 2 points, is that going to cross out of the, is that ever going to go outside the box? No matter where I pick a point inside the box, it's not going to go out there, okay? Now, concave is like it's dented somewhere on a side, okay? So let me show you what I mean by this. Let me draw this. How about you draw well, let's draw maybe a shape that looks like this. Ah, shoot, that did not go the way I wanted it to. Assume all sides are straight right here, okay, kids? Are you with me on that? Okay. Let me ask you a question. Up here in this one that's convex, I said, hey, no matter where I pick 2 points, if I draw a segment between 2 points, that line segment will always be inside the box. Is it possible now in this other one, which we're saying is concave, or what did I put down here for our phrase? Dented. Concave says this. Not all line segments will lie inside of the figure or the polygon. In other words, it's kind of dented in some places. Is it possible I could pick 2 points, and after connecting those 2 points, that one line segment between the 2 points might travel outside of the figure? Okay, give me an idea of where those would be. Say again? So maybe like up here? Is that what you're saying? And maybe down here? Okay, guys, if I connect this, does it look like this line segment traveled outside those figure? Does that make sense to you? Okay, these 4 walls in here right now. These 4 walls. Concave or convex? Pick 2 points inside these walls. Concave or convex? It's convex. Well, you're not going outside. Okay. All right. Think about the hallway that's out in front of Mrs. Olson's room that connects with the hallway all the way down the academic wing. Got that shape? That shape concave or convex? Concave, right? Okay. All right. I think you got it. Guys, a regular polygon is any polygon with all, this is what you need to highlight, all sides equal in length and all angles are what? Equal. Okay. If you have equal sides and equal angles, then it's considered what kind of a polygon? Regular, you bet. Okay, you guys ready to move on next page? All right, guys, classifying polygons. First of all, we need to tell how many sides there are. It says classify each polygon by the number of sides. Tell whether it's convex or concave. Kids, let's count the number of sides in this first one. I've got side 1, side 2, side 3, side 4, side 5. How many sides are there? Any of you guys recall the name of a 5-sided figure? Okay, it is a polygon. Yep, it is. Specifically, it is a what? It's a pentagon. Okay, and maybe I should go through these. You said 4-sided figure was quadrilateral. Prior to that was triangle. 5-sided is pentagon. You guys remember 6-sided? Hexagon. Tough one is 7. You remember 7? 7-sided figure is called a heptagon, or sometimes they call them a septagon. Okay? September gets its own gon. Heptagon, septagon. Okay? Anybody recall an 8-sided figure? Octagon. 9-sided is nonagon. How about 10-sided? This is a tricky one. Say it again. Decagon. Okay, decagon's like decade. How many years is a decade? 10 years. Okay, so decagon. Okay. Next question. Concave or convex on this figure? Okay, pentagon and convex. How many sides to the next figure, my friends? Count them. 6 of them? Okay, let me double check. 1 side, 2 side, 3 side, 4 side, 5 side, 6 side. Absolutely. What's the name of a 6-sided figure again? Hexagon. Okay, how about this one? Concave or convex? Why are you saying concave, my friends? Okay, so if I pick how many points? 2 points. Is it possible, like if I pick a point here and a point here, would that line segment stay within the figure, or would it have to travel outside of the figure? It's got to go outside there. Okay, so this one's going to be concave. All right, guys, the way I remember concave is it's like it's caved in somewhere. Okay, this part right here kind of caved into it. That's how I remember it. All right, so guys, classifying polygons as concave or convex and naming them by the number of sides. Are we okay with that right now? Yes? Perfect. Let's move on, my friends. We need to recall some perimeter and areas, okay? We really need to make sure we understand the areas of triangles and parallelograms, okay? I'm going to ask you a question. I'm asking you to recall some things from prior math classes. Anybody recall the area formula of a triangle? You're thinking of distances around there, Pythagorean theorem in a right triangle. That's a good thought right there, but not quite where we need to be right there. Yep, yep. Here's what I'm going to do. I'm going to talk to you about this right here. I'm going to give you this formula for triangles that I think you should use. We're going to go base times height divided by 2. Okay? Now, kids, whenever I talk about a base and I talk about a height, okay, let me ask you a question. If I consider the floor to be a base that I'm standing on right now, how do you measure height from that base? You measure it like this. You measure it like this. Or the third one, you measure it like this. Straight up and down. So the implication is, what angle are we really forming with a base and a height? A right angle. It has to be a 90-degree angle. So understand this. When I ever talk about base and height, there's 3 sides to a triangle, right? You care about the 2 sides that form what angle for a base and a height? What's that angle again? For a base and a height? It's going to be a 90-degree angle, okay? It's going to be the right angle. So I'm going to make a note right here. Is it okay if I say B and H form what kind of an angle? call the area formula for any parallelogram? The area of any parallelogram is just a base times a height. Okay? It's just a base times a height for that. All right? Okay, I'm going to jot these points down on the board up here. Okay, I'm going to move on here. This P, Q, and R. Okay, everybody have what they need there, friends? Oh, we are moving right along. This is awesome. I don't think we're going to get all the way through this. Okay, kids, I have this graph paper right here for the one we're about to graph. Okay, on there it says, first of all, graph P, Q, and R, doesn't it? At the following coordinate. I'll just write them down on the board because it's shifted over to this different side. Okay, what does it tell us up here on the board that P has to, where does that have to land, my friends? So I'm going to go left 1 and up 4. Would you guys agree with that? Okay, and we're going to label that point what point? Okay, what's my coordinate Q? Right 2 and up how much? Okay, and this point is Q. And then where's my R value, my friends? Right 2 and down how much? Okay, and this is R, isn't it? Kids, when I connect those points right here, it looks like this forms a what for us? Right triangle, doesn't it? Okay. So I think for today's purposes, I think I'm going to have you get this sketched right here. What's that? We're going to label PQ and QR, and then we're going to pick this up again on Tuesday when we get back here. Okay. Guys, what's the length from P to Q? We know that this is 3, don't we? What's the length from Q to R? 5. We can always count vertical and horizontal distances, can't we? What are we going to have to use to find P to R? Exactly. We're going to pick that up on Tuesday. So before I turn you loose today, make sure you have this diagram down, and then kind of be thinking about distances and stuff. We're going to pick this up tomorrow. I will let you know. Big Ideas is open. You know, you may not get through all of it, but I think you've got a good background to at least get started on what's assigned there, okay? That new Big Ideas isn't due until Wednesday of next week, all right? So I'm going to go ahead and stop there. You guys have any